In this presentation, we are going to talk about the measurements and conversion units. Please complete the problems, the appendix D. First, let's talking about the quantifying properties. Quantifying is the act of counting and measurement. And why this is important? Because when we counting or we are able to measure something, then we are able to understand better the observation and the experiences. Then let's see if we are talking about the long fingernails. Then what happens if we say long fingernails? What is the length? What is the length of the long fingernails? Then for me, these are long fingernails. Yes, but maybe someone can say, no, these are not long fingernails. These are long fingernails. Yes. But someone say, these are not long fingernails. These are long fingernails. Then the idea of the long fingernails is different from each people. Then in science, we need to eliminate that. Yes, because in science we need to eliminate any weakness of communication. This is why in science we need the standards measurements. The standard measurements allowed us to make comparisons between objects. And also, if we had standard measurements, we need standard units. And these standard units make it possible to communicate and duplicate measurements. If we had standard units, everyone is going to understand the same. Yes, for example, if we say 5 feet, then here all people will understand the same thing. Yes, what is the length of 5 feet? The measurement is a process in which we compare a property with a well-defined and agreed upon reference. For example, if we want to measure the length of the table, then we can compare the length of the table with the inches. How many inches we have that particular length? Yes, then we can say is 20 inches or 15 inches. Then we compare a property, the length, with some particular unit. Then in this picture, we can describe this. We can measure the distance between these two hypothetical series using different units. As here we have the list of different units, but only the units that are officially adopted, it becomes now known as a standard unit. Yes, not all the units are standard units. Only those measures that only those units that are officially adopted. Then let's now talking about what is the process, what are the steps we need to follow when we need to measure something. Yes, we need to measure some property. Then the first thing we need to do is to comparing the reference unit to that property, yes, that we want to measure, that we want to describe. The next thing we need to do is to follow some procedure. Yes, we need to follow some procedure to complete that measurement in the correct way. And the next thing we need to do is we need to counting is how many standard units describe that particular property. And in this example, we want to measure the length of these two pens, as we want to measure the length of this pen. Then what we need to do is we need to compare the length, which is the property we want to describe, with this unit in the upper part. In this part, we want to compare with the centimeters. Yes. How many centimeters are in this length? Then in this case, what procedures we need to follow? We need the pen should be parallel to the meter, to the scale. Yes, should be parallel. Yes, if it's not parallel, then the measure is incorrect. Then we want to count how many. Then how many units are in this length? Then 1, 2, 3, 4, 5, and then we can say is about 5.20 centimeters. And we can use this unit, but also we can use inches. Yes, we can use inches to describe. Then we can describe the length using different units. Always when we report a measurement, we need to report 3 different things. Yes, the first thing, we need to report the numerical value. And the numerical value in this case will be 5.20. Yes, this is the numerical value. The unit, then the unit in this case is centimeters, is in the second example is inches. And it's important, the unit, because by the unit we know the type of measurement. Yes, we need to know what is the property we are reporting. For example, if we had 5.20 centimeters, we know this property corresponds to the length. Yes, this measurement we did correspond to the length. Why? Because centimeters are units of the length. Then the measurements are important because we use measurements to describe a natural phenomenon. Always each measurement is associated with a physical quantity. Yes. Then again, length, because it's easier to understand that, but can be also mass. Yes. If we report pound or kilograms, we know this corresponds to mass. And when we report in science on measurements, we need to use standard units. And let's now talking about what are the fundamental quantities and what are the standard units I use it in science. Then in science we had some fundamental quantities that are the basis of all measurements. Then the 3 first fundamental quantities we are going to study is the length, mass, and time. Then the length, these are the different units in which we can measure the length. Yes, can be miles, can be feet, can be yards, can be meters or kilometers. Mass can be kilograms, can be grams. Time can be second, hour, and day. Then these 3 are fundamental quantities. Then we had these 3 fundamental quantities, and in science we had some system of units which in this system of units they define what are the standard units I use it in science, right? The standard units. Then I have the example for 3 different systems of units, and these are the systems we are going to use in this class. Then here we define what are the standard units for each of these 3 fundamental quantities. For example, in the International System of Units, or SI system, the length is measured in meters. Yes, and this is the symbol for the meters. The mass is in kilograms and the time is in seconds. Another name for the SI system, or the International System of Units, is MKS. This is because of meter, M for meters, K for kilogram, and S for seconds. And this is one way you can maybe remember that. The English system that is mainly used in England and in USA, then length is measuring foot, the mass in a slug. We are not going to use much this measurement, this unit, but just I want to say this is the unit for mass in the English system. And time is in second. In the Gaussian system, the length is centimeters, mass is in gram, and time is in second. And also this system is called CGS, C for centimeters, G for grams, and S for seconds. One thing maybe you can see is time is the same unit, as is the standard unit for time is the same for all three systems. But in science, this is the system is most frequently used, is the international system or SI system. The English system was based on arbitrary units, because most of the units correspond to part of the human body. But since 1960, this system was defined in terms of the SI system. Then now this is why we consider these units as standard units. As we mentioned in the previous slide, in 1960, the units of the English system became a standard units. But it was a problem with the early units because they were based on the length of the foot or the thumb of the kings. Then that measurement depends on the length of the body part of some particular king. But that changed when the units of the English system was standardized using the SI system, or was defined based on the SI system units. There are some more basic units. For the first chapters of we will focus on these three basic units: length, mass, and time. There are some another units we will cover later. Some of them are electrical current. There are the units of temperature. The last two we are not going to discuss in this course. Now we are going to talk about the metric prefixes. The metric prefixes are prefixes that correspond to power of 10. For example, we have here 10 to the power 3. Yes, 10 to the power 3. And this power of 10 corresponds to some prefix. Each prefix has a specific name. For example, 10 to the power 3, the name is kilo. Yes, kilo. And each prefix has a specific abbreviation. The abbreviation in this particular case is K. It's kilo. The abbreviation is K and means 10 to the power 3 means 1000. And these prefixes can be used with any basic units. Yes, with any. For example, if we use with meter, then we will have 1 kilometer equals to 10 to the power 3 meters. And also we can say equals to 1000 meters. But we can use also the same prefix with grams. Is the unit for mass. We can use 1 kilogram and means 10 to the power 3 grams. We are using the same prefix but with different basic unit. Yes. And in this particular case we had 1000 meters, but here we had 1000 grams. And we can use also different prefixes but using with the same unit. In this case we had kilometer. In this case, we had millimeter. Yes, millimeter is 10 to the power minus 3 meters. And we can also express using the same prefixes, but we can use different units. We can use gram. Then 1 milligrams equals to 10 to the power minus 3 grams. Another prefix is pico. Yes, picometers is 10 to the power minus 3 meters. Sorry, minus 12 meters. And this is really a small number. And we use this one mainly when we are talking about the length at atomic level. The other prefix we can use is nano, means nanometers, because we have M here with nanometers. It's 10 to the power minus 9 meters. Yes. All of these are prefixes, and we can use this prefix with any standard unit. Also, we had another kind of quantities, which are the derived quantities. And these derived quantities, for these derived quantities, there are some derived units. And the derived quantities are based or are expressed in terms of the basic units. Remember, the basic units are length, mass, and time. And these derived quantities are expressed in terms of that basic units. And one example of the derived quantity is the area. The area, remember, is the surface. Yes, is related to the surface. And the area is expressed, or it can be described by two length measurements. Remember, the area is length times width. Basically, is the multiplication of two lengths, as we had here two lengths. And in this case, the basic unit is the length, and the derived unit and the basic property is the length, and the derived property is the area. Now let's see the units. In this case, the unit of area can be meters times meter, because we have length times length, as is meter times meter. Then we will have square meters. Then the basic unit is the meter, and the derived unit is the square meters. But can be also feet. Yes, feet times feet is square feet. Then in this case, the basic unit is feet, and the derived unit is the square feet. And the same happens in case of the volume. Volume is a derived quantity because it's the multiplication of three different lengths. Yes, length, width, and height basically is the multiplication of three different lengths. And the same thing happens with the units of volume. Yes, the units of volume are always cubic units. Then for it can be, one example is cubic meters, cubic feet. Yes, is the multiplication of meters times meter. Each of these meters correspond to each of these lengths. Then one important thing is we can identify the units are important because we can identify the property by the units. If we had 5 square meters, we know this measurement corresponds to some area. And by the units, we know that. If we had 7 cubic feet, we know this measurement corresponds to some volume, because the measurement we are reported is with cubic units. In this case, we had two more derived quantities, and the derived units. One derived quantity is the velocity, and the velocity is the ratio between distance and time. Remember, distance is a length, time, these two are the basic units, yes, length and time. Then what are the possible units for velocity? Yes, it's miles per hour, and these miles per hour are the derived units that correspond to the velocity. Another unit can be kilometer per hour, yes. And the other unit in the SI system, for example, can be meters per second. Then all these are derived units, and the velocity is a derived quantity. Another example is the density. Density is mass over volume. We know mass is a fundamental quantity, but volume is itself a derived quantity, as we already discussed that. Then the units, the derived units for density can be grams over millimeter over milliliter, and grams per milliliter, grams for cubic centimeter. Yes, can be another unit for density. And in SI system, the unit for density is kilograms per cubic meter. And all these are units of the density. And these are derived units. These correspond to derived quantity. Another important thing we need to discuss is the conversion of units. And this is important because sometimes we want to change from one unit to another unit. And the reason we want to change from one unit to another unit is usually because we need two consistent units when we are trying to solve problems, or when we are trying to compare two lengths or two masses, and we need to have the same unit in order to compare them. Then, for example, if we are solving one problem, yes, and the time is in seconds and the velocity is in kilometers per hour, we see here the time is hours, and here the time is in seconds. When then we say the units are not consistent, we need to do something. We need to change maybe the time. We need to change the seconds to hours. In this way, we will have consistent units. If the problem we had to solve, the time is in hours and the velocity or the speed is in kilometers per hour, then we say we have the same units. The units are consistent. In this case, time is in seconds, but the velocity is meters per second. Then we say, okay, no problem. Time is in the same units, then in the same unit. Then we say the units are consistent. Another important thing is when we add or subtract, or multiply or divide measurements, then the units, we can operate the units like if they were algebraic quantities. We can add quantities if they have the same unit. We can cancel units if we had meters on top and meters in the denominator. In the same way, we can cancel numbers as if they were algebraic quantities. In order to convert one unit into another unit, we need to use the conversion factors. Then to know the conversion factors, we need some equalities. For example, in this case, we know this equality is 1 feet equals to 12 inches. Then just to explain what we can use the conversion factors, we will do this one just one time, okay? And if we have this equality, then 1 feet equal to 12 inches, we can divide by 1 feet on both sides of the equation. Yes? If we divide by 1 feet, 1 feet divided by 1 feet, we will have this equal to 1. Yes, this is what we had here. And we had 1 equals to 12 inches divided by 1 feet. But also, if we had the same quality here, we can divide by 12 inches on both sides. Yes, we can divide by 12 inches. And in this case, we will have that 1 feet over 12 inches equals to 1. Yes, we had here 1. Yes, 12 inches divided by 12 inches equals to 1. Then when we multiply by the conversion factors, we are really multiplying by 1. This is why when we multiply any number by the conversion factors, we are not changing the number because we are multiplying by 1. Yes. Then this ratio is we call the conversion factors, and we use these conversion factors to convert from one unit to another unit. And let's see what are the steps we need to follow if we want to convert one unit from one unit to another unit. The first thing is we need to use the appropriate conversion factor. And depending on the problem, you need to decide if you are going, for example, if you need to convert from feet to inches or to inches to feet, you need to decide if you are going to use this conversion factor or if you are going to use this conversion factor. Yes. Then you need to use the appropriate conversion factors. Then the next thing you have to do is you need to multiply the number by the conversion factors. But when you multiply, the unit you don't want must be canceled out. And then the result will be in the unit you want. Yes, in the unit you want. And we will explain this one now. One more thing is when we need to determine the significant figures of the answer, we don't take into account the significant digits of the conversion factor. Okay, we don't take into account the significant digits of the conversion factor. And let's try to solve this problem. Follow these 3 steps. We want to convert 3 feet into inches. Yes, 3 feet into inches. And we know we need to use this equality, but we need to write the correct conversion factor. Then how we know what is the correct conversion factor? Then the correct conversion factor is the fact in which we can cancel out the unit we don't want. Yes, and we know we must use this conversion factor in this case because it's the only way the feet cancel out. Yes, it's the only way the feet cancel out. And if the feet cancel out, the answer is in inches, which is the unit we want. Yes, this is why we need, in this particular case, we need to use this conversion factor. Then 3 times 12 will be 36 inches. One more thing is we had here 1, 2, 3 significant digits. Then the answer must have 3 significant digits. We don't take into account the significant digits of the conversion factor, just the units of the number we want to convert. Yes. In this example, we want to convert 16.5 feet to inches. Then the information we know, the equality we know is 1 foot equals to 12 inches. Now we need to know how to write this equality, how we can write the conversion factor in order to cancel out the feet and get the answer in inches. And let's write, and we had 16.5 feet. Then now we need to write the conversion factor. The only way the feet cancel out if we write 1 foot in the denominator and 12 top. And this is because this feet on top and this feet on bottom will be canceled out. Yes, will be canceled. Now we multiply this, like we can think they are fractions. We multiply numerator times numerator will be 100. Then 16.5 times 12 will be 198. and inches, as this is the unit we want, as the fit the cancel out. And in the denominator we had is we can think we had 1 times 1 is 1, and here we had 16.5 feet equals to 198 inches. And one more thing, we had 1, 2, 3 significant digits. We had 1, 2, 3 significant digits. We don't take into account the significant digits of the conversion factor. Then let's try the next problem. And in this, we want to convert 2.5 centimeters to meter. And that's why here the number we want to convert. The next thing is we need to write the conversion factor, the appropriate conversion factor. Then we need to write this in the way the centimeters cancel out. And the only way if we write 100 centimeters in the denominator and 1 meter on top. And these two cancel out, and the answer, final answer, is in meters. Then you can skip this step, but I will write just to explain. Then now we need to multiply. You can think you had 1 here. It's 2.5 times 1 is 2.5. Remember, it's like fractions. We are multiplying fractions, meters, because centimeters cancel out. And 1 times 100 is 100. Then 2.5 divided by 100 equals to 0.025 meters. And now we can write 2.5 centimeters equal to 0.0 meters. And here we can see we had 1, 2 significant digits. We had 1, 2 significant digits. Yes, we don't take into account the significant digits of the conversion factor. Let's try the number 3. Here we had one prefix, yes, is kilo, means 1,000. Yes, this is 1 kilometers equals to 1,000 meters. Then here we want to convert 25,000 meters to kilometers. Then 25,000, let's write first the number is 25,000. Now we need to write the conversion, the appropriate conversion factors. Here is meter. Then we need to write in the way the meters cancel out. Yes, we need to write this, the appropriate conversion factor. Then 1,000 must be in the denominator and 1. Then in this way we cancel out the meters, and the answer is in kilometers. And here 25,000, you can use your calculator, but also you had 1, 2, 3 zeros in the denominator. We had 1, 2, 3 zeros here. We can cancel out. Then the answer is 25 kilometers. But if you want, you can write here like 25,000 kilometers divided by 1,000. Yes, and you can use your calculator if you want. It's 25. Then here we can write that 25,000 meters equal to 25 kilometers. And here we can see we had 1, 2 significant digits. We had 1, 2 significant digits. We don't count these zeros because here we don't have explicit decimal point. Now let's convert 125 kilometers to meters. Then we can use the same conversion factor, yes, the same equality. Now we need to write the correct conversion factors. Then we need to write the conversion factor in the way the kilometers cancel out. Then 1, and we need 1,000 on top. Is the only way this unit cancel out with this one. And now just we multiply. It's 125 multiplied by 1,000. And the units is meters. And now we can write the answer. We had 125,000. We had 125,000 meters. And again, here we had 1, 2, 3 significant digits. We had 1, 2, 3 significant digits. Let me write here. Yes, like that. Now let's solve the last problem. We had 3.000 hours to milliseconds. Yes, milli to milliseconds. Then there is 2 ways we can use these 3 different conversion factors. If we need to use more than one conversion factor, it's called we need to use a change of conversion factors, yes, to solve the problem. This is the case we need more than one conversion factor. Then we can use here 1 second equals to 1,000 milliseconds, and the other conversion factors you can use in this case is 1 milliseconds equal to 0.001 second. Yes, but it's easier to remember this. Yes, you can use either this one or this one. They are the same. They are the same. You will get the same answer. And let's use the 3 equalities we had here to get the answer. And we start here with 3. Let me look at 3 again. 3.00 hours. And because we don't have any equality that correlate hours with milliseconds, then we need to use these 3 conversion factors. Then 1 hour, and the first thing we want to do is we need to convert hours into minutes. And to convert hour into minutes, then we will use this equality. Yes. Then 1 hour, 60 minutes. Again, we need to write 1 hour in the denominator because it's the only way we can cancel out the hours. But we don't want the answer in minutes. We want the answer in milliseconds. Then now we will convert minutes into seconds. Then now we can convert minutes. 1 minute, 60 seconds. Then we will use the second equality, and in this way minutes cancel out. But we don't want the answer in seconds. We want the answer in milliseconds, and we will use the last conversion factor, which is 1 second, 1,000 milliseconds. As this second cancel out, and now the answer is in milliseconds. Is the unit we want. This is the unit we want. Now, how we will solve this is just in the way we multiply fractions. Yes, we multiply fractions, numerator with numerator and denominator with the denominator. When we will do the same. And again, you can skip this step, but I will write here. And it's 3.00, and we have to write all these zeros because means we had 4 significant digits. Yes, this is why we need to write, because signs are important. This is telling you had 4 significant digits. Then multiply by 60. Let me write multiplication in the other way. Multiply by 60. Multiply by 60. Multiply by 1000. And here the answer is milliseconds. 3.00 times 60 times 60 times 60 times 1000. Yes. Over 1 times 1, 1 times 1, then it's over 1. Yes. No units, because all these units cancel out. And if we multiply this number together, we will get and we will get 10,800,000. Yes, 10,800,000 milliseconds. Yes, then we can write this one because it's a big number. We can write this one in scientific notation. Yes, just to practice. Then we had here, we want the decimal point here. Yes, how many places we need to move? 1, 2, 3, 4, 5, 6, 7. And it's big number. We know the power of 10 must be positive. Then 1.08. And I need one more 0 because we need to give the answer 1, 2, 3, 4 significant digits. 10 to the power 7 milliseconds. Then now we can say here 3.00 hours equals to 10,800,000 milliseconds. This is one possible answer, but also we can write 10 to the power 7 milliseconds. And these two both are correct answers, as both are the same thing. This is in standard notation, this is in scientific notation. But one thing you can see here is, in this case, we can see clearly we had 1, 2, 3, 4 significant digits. But in this case, this is one of the cases we cannot write the standard notation. Yes, we cannot express the number of significant digits in this case in standard notation. Then if we want to express the correct number of significant digits, it will be better to write in scientific notation. Then there are many standard unit quantities. You don't have to memorize these equalities, but you need to know how to use when you convert one unit to another unit. The next thing we want to know is how we need to convert derivative units, and we will start with the area units. It's important this part because you will use this in your lab number 1. Then we want to convert 2,880 inches squared to feet squared. And here this we had explicit decimal point, means we had 1, 2, 3, 4 significant digits. We had 4 significant digits, and then we need 4 significant digits in the answer. And in this case, I wrote here all the steps. And this is the number we want to convert, but here we had to be careful because we had square units. Yes, we had square units. Then the only way we can cancel out the units, we must have square units on top and square units on bottom. Then what we will do to get that? Then first thing, we will write the conversion factor in the appropriate way. As we had inches on top, we need to write inches in the denominator. Is the only way we can cancel out. But what happens is, can we cancel out square inches with just inches? The answer is no. This is why we need to square also the conversion factor. This is why we had this square. But we need to square not only 12 inches, we need to square all the conversion factor. And remember, if we had in this case, we need to square the numerator and the denominator. Yes. And let's go to the next step. Yes. And the first thing, we need to write the appropriate conversion factor, and we need to square the conversion factor. Yes. Now this is the same we had here. Now 1 feet squared is 1 times 1 is 1. This equals to 1 feet squared. 12 inches square is 145. Let me write here. Then if you had 12, we have 12. We need to square. This one is like 12 inches times 12 inches. Then we have 12 times 12 is 144 inches. Inches times inches is inches squared. And this is why 12 inches equals to 144 inches squared. Now we had inches, square inches on top, square inches in the denominator. Now we can cancel out these units, and we had the units we want. Yes, this is the unit we want. Now we just the same we did before. Yes. Then we 880 we divide by 144, and we get 20 or 20. But here we had to be careful because we need 1, 2, 3, 4 significant digits, and we need to write the answer using the correct number of significant digits. Then 1, 2, 3, 4, we had 1, 2, 3, 4. And the units are feet squared. Then remember, here we divide 2,880 divided by 144. Yes, this is how we got 20. For the next problem, we want to convert 34,500 square centimeters to square meters. Then this is the conversion factor. We know 1 meter equals to 100 centimeters, but we have to be careful when we are converting area units, because we need to square the conversion factor. Yes. And in this case, this is the number we want to convert. This is the appropriate conversion factor, and we know this is the appropriate because centimeters cancel out with centimeters, but we need to be careful. Here we had to be careful because we need to square the conversion factor. Yes, it's the only way we can get square centimeters on top, square centimeters in the denominator. Then we square the conversion factor. 1 meter squared is 1 square meter. Yes. 100 centimeters to the second power is 100 times 100, which is 10,000. And if we square the centimeters, we had square centimeters. Yes. And we square this number, square this number. Now you can see here we can cancel out this. Yes. Now we had the same units. So we had square centimeters, we can cancel out these units. And the answer is in square meters, is the unit we want. Then again, what to do? We divide 34,500 divided by 10,000. And then the answer is 3.4500. We had 1, 2, 3, 4, 5 significant digits. We had 1, 2, 3, 4, 5 significant digits. Then this is the answer is 3.4500 square meters. Here we had 2 more problems related to the conversion of unit areas that I would like you to review. Let me know if you don't understand one of the steps. I try to write step by step, but let me know if you don't understand something. Now we will learn how we can convert the velocity or speed units. Remember, the velocity are the derived quantity, and in this particular case we want to know how to convert kilometers per hour to meters per second. To convert this unit into this unit, we need this information. Yes, we need to know 1 kilometer equals to 1,000 meters, 1 hour 60 seconds, and 1 minute 60 seconds. And let's write 25 kilometers per hour, and let's convert first the kilometers to meters, as this is the first thing we want to do, kilometers to meters. Then for that we will use this information. Yes, we will use this information. And now how is the correct way we can write this one? Kilometers on top, then kilometers should be in bottom, and the other will be on top, will be 1,000 meters. It's the only way we can cancel out the meters. Yes, and we had the answer in meters, and this is the unit we want. Yes. Then we're done with the denominator. Now with the numerator, yes, we had the answer in meters. Now we need to take care of the denominator, which is we want the units in seconds. And we had the units in hour, then we need to convert this one into seconds. To do that, we will use the other conversion factors. We will use the second one. Then the correct way is 1 hour over 60 seconds. Is the only way this hour cancel out with this hour. But we don't want the answer in minutes. We want the answer in seconds. And this is why we need to use the third conversion factor. Yes. Then we need to multiply what 1 minute over 60 seconds. And we know this is the correct way to write the conversion factor because it's the only way we can cancel out the minutes. And now we had the answer in seconds. Now you can see here on top we had just minutes, and in the denominator we had just seconds. Yes, meters per second, which are the units we want. Meters over seconds. Yes. Now to do the math, just you multiply as they were fractions. Then 25 times 1,000 is 25,000. What we had in the denominator is just 60 times 60 is 3,600 seconds. And this is the unit we want. When we divide, if we divide these two numbers, we will have the answer is 6.944 meters per second. But now, because we had two significant digits here, we want two significant digits in the answer. This is why the correct answer is 6.9 meters per second. Then we need to round down the number to get the correct answer. Then 25 kilometers per hour equal to 6.9 meters per second. Let's try the second example. We have 60 miles per hour to feet per second. Then we will follow exactly the same procedure, and the information we need is this one. Yes, this one. Then 1 mile equal to 5,280 feet. And let's convert first the miles into feet. Yes, then we will use the first conversion factor. And we know this is the correct way we need to write, because this is the only way the miles cancel out, and we had the answer in feet. Then with that, we're done with the top part with the feet. Now we need to take care of the denominator. We need to convert hours into seconds. Then the only way to cancel out the hours is if we use the second conversion factors. We convert hours into minutes. Yes, we convert hours into minutes. These hours cancel out. And now we had 60 minutes. But now we don't want the answer in minutes. We want the answer in seconds. Then we need to use the third conversion factor. Yes, this one is right here. And we should write 1 minute over 60 seconds. Is the only way we can cancel out the minutes. And now we had the answer in seconds. This is, we want feet per second. Yes, we had feet per second. Yes. Now we can see on top the only unit we had is feet. So about this one is not meters. Here it should be feet. Yes, it's feet per seconds. And we multiply here as if they were fractions. Yes, 60 times 5,280 is 316,800 feet divided by 3,600 seconds. Yes. If we divide these two numbers, the answer will be 88 feet per second. Then we can say, and you can see here we had two significant digits. We had here two significant digits. And 60 miles per hour equals to 88 feet per second. Then this is the answer. Then this is all I had to discuss for today.